This video is to go over homework investigation 4D. Let's go over, I'm just going to pick one problem for each lesson. So I'm going to pick number 6 for lesson 4.14. So it says, in the figure, triangle ABC is similar to triangle CDE. Decide whether each statement is correct or incorrect. So the goal of this problem to say, it's kind of like a yes or no question, right? So let's look at A. Triangle ABC is similar to triangle DEC. So what we need to do is to decide. What we know is triangle ABC is, so this big triangle is similar to triangle CDE. So as you look at it, okay, the left letter of this expression is A. B is in the middle, C is in the right. And for triangle CDE, C is on the left, D is in the middle, E is in the left, the right. So these orders are very important. So this implies that A matches to C, B matches to D, C matches to E. Or in other words, C corresponds to it. Another way to look at it is to take this CDE and put it in a way so that it looks like, so you can see it better. So here we have C, which is the acutest one, and D is the obtuse one, and E is here. As you see, then A corresponds to E. Oh, I'm sorry, I made a mistake. Oh, this is E, and this is C. Sorry. So as it says right here, A has to match with C, so A has to go with C, and B to D, and C to E. So let's look at it. Triangle ABC is similar to triangle DEC. So you got to look at it. This statement is wrong because A should match with C, but here A is to D, so this is not good. For B, let's check each pair. B to D, which is good. C to E, it is good. And A to C, this is good. Okay? This is how you do it for problem number 6. Let's move on to let's do number 7. Okay? The side of a triangle have lengths 4, 5, and 8. Another triangle similar to it has one side of length 3. What are the lengths of its other two sides? Is more than one answer possible? So let's look at it. What's the goal of this problem? The goal is to find the length of its other two sides. And also we have to answer this question, which is more than one answer possible? That has to be yes or no. What do we know about this problem? We know we have two triangles, one with the length 4, 5, 8. Another triangle similar, this is very important, to it has one side length 3. So one good thing to do to approach a problem is to draw. So let's draw a figure. So we have triangle 4, 5, and 8. We have another triangle that are similar. It could be smaller or it could be bigger, right? So where is 3? 3 could be actually anywhere, right? 3 could be here, or 3 could be here, or 3 could be here. So answering that question, there are actually 3 possible answers depending on which part you're going to put 3. So let's suppose you have 3 here. So as you see, 4 corresponds to 3, right? So 4 corresponds to 3. In other words, 4 times some number k has to be equal to 3. So k is 3/4 by dividing by 4 to both sides, like this, right? So this is the scale factor, right? So the scaling means to multiply each side by a number which we call scale factor, right? So scale factor, if you put 3 here, scale factor is 3/4 now. So you're going to multiply 3/4 to 5 and multiply 8 by 3/4 to find these answers right here. So you should have 5 times 3/4, right? We can multiply integers and fractions, so you're going to have to change this 5 into fraction. Then side by side. So right here, this should be 15/4. And then you do the same thing to get the answer for this one. Okay, so that's why we were doing it. But what if you put 3 instead of putting there? What if we put 3 here, right? Instead of having 4 here, we should have 5. So the scale factor will be 5/4. And that's the number that you want to multiply by 4 and 8. So we do have more than one answer. Finally, let's look at 4.16. The area, should we pick which one is the easiest one, right? Which one is the important one? So let's do problem 5. It says, use scale a rectangle by the factor 1/4. Compare the area of the scaled rectangle to the area of the original rectangle. So what is the goal here? We have to compare the area. The areas, right? 2 areas. So it's always good to draw a picture because people usually like problem with picture rather than without picture. So let's say we have a rectangle, random rectangle. Let's say 3 by 8. I'm just making it up, right? And we're going to scale this rectangle by the factor 1/4. So by the factor 1/4 means that we're going to multiply each segment by 1/4. So we'll definitely have smaller rectangle, but the shapes are similar. One side here is 3 by 1/4 is 3/1 times 1/4. Multiply side by side, you get 3/4. So it's going to be 3/4. 8 times 1/4 will be 8/1 times 1/4, which is 8/4, which is 2. Okay, this is not the end, because the problem says compare the area. So we have to find the area here. So the area of this rectangle is pretty easy. That's 24, right? Because 3 times 8. Area of the smaller rectangle will be 3/4 by 2, which is 2/1, right? That's going to be 6/4. Since 6 and 4 are multiple of 2, so we can divide both number by 2. That's going to give you 3/2. So the area is 3/2, right? So let's compare. What does it mean by compare, right? That is to say, is this smaller or bigger? How many times? Or how many times this one is smaller or bigger? So it's definitely smaller, but how many times smaller, right? So that's the question here. So you compare 24 and 3/2, right? You multiply some number to 24, to get 3 hubs. So we're gonna, let's say we are multiplying by, I don't know, maybe x, some number x, so that we get 3 hubs. You know how to solve this one, right? Divide both sides by 24. So the x will be equal to 3 hubs divided by 24 over 1. You can definitely flip the second fraction and multiply out like you learned in middle school, but I'll show you how to do kind of different ways so that you know other way to do it, right? So just like adding and subtracting fractions, you can have a common denominator. So we'll have 3 over 2 divided by, we want this one to be 2, so we want 48 over 2. Right? I multiply 24 by 2 and 1 by 2 to get 48 over 2. So you get 3 divided by 48 over 2 divided by 2. So we'll get 3 over 48 over 2 divided by 2 is 1. But 1 is, we know it's 1. Divide whatever this divided by 1 is itself, so it's 3 over 48. Both numbers are multiple of 3, so you can divide it by 3. So you'll get 1 over what? 16? Okay? So that number tells you that this rectangle is 1/16 of the big one. I actually told you the answers. I'm not supposed to tell you the answers, but anyways, yeah, this is it.